All right, class. We've pretty much come to the conclusion that plates on our planet are moving around. So the question is, what happens when those plates interact with each other? Well, plates on the surface, they can pull apart from each other, they can rub against each other, and they can crash into each other. And so those are the different types of interactions that they can have. And when they do that, it creates many of the land features that we see today. So we're talking about mountains, volcanoes, trenches, valleys, islands, uh, volcanoes. A lot of that stuff is created because plates move around and plates interact with each other. All right, you're going to be taking your notes on this note page, filling out the whole thing top to bottom as we move along. And if I go too fast again, feel free to pause or stop things as we're moving along here so that you can get all the notes that you need. Okay? All right, so one thing we have to talk about before we move on is called subduction. It's kind of one of our fancy science terms, but if you think about this, a submarine is where? Well, it's underwater. So when we talk about subduction, this is a plate, one plate going under another plate, okay, being subducted underneath another plate. And the reason why this generally happens is because one plate is less dense than the other, and the less dense one will stay above, and the more dense one will go underneath when this happens. In this diagram that you see here. So what we have in this is we have an dense oceanic crust running into less dense continental crust. The continental crust stays on the top, the oceanic crust goes underneath, and this leads to a whole host of other things happening as a result of that. So please make sure that your diagram gets filled out and you get all the blanks filled out in your notes. Okay. Next up is all the different types of plate boundaries. There are 3 different types that you need to be aware of. The first one is called a convergent plate boundary. This is where plates are coming together. And we have a variety of those. We can have continent to continent coming together. In that case, when they come together, neither is lighter, so they push upward like this, which leads to mountains. We can have continent to ocean. We know continent's going to stay on top and ocean's going to go underneath. This is going to cause volcanic islands, not volcanic islands, volcanic mountains, like the Cascade Mountains, like the Aleutian Islands off the coast of Alaska. And then we can also have ocean to ocean running into each other, and one of them will be more dense and go underneath, and that leads to trenches. It leads to chains of volcanic islands, and that's how we get a lot of the different features that we see. So divergent, the opposite of converging is splitting apart. We can have continental crust splitting apart. We can have oceanic crust splitting apart. If it's oceanic crust, we're going to form that mid-ocean ridge that you're familiar with. If it's continental crust, we're going to form a rift valley. And this is like what is happening in the eastern part of Africa. There is a rift valley forming there that scientists think eventually in about 1 million years will split off and create a new island bigger than Madagascar off the northeast coast of Africa. So kind of wild. And then the last one is a transform boundary. This is where plates are moving side to side against each other. This can happen in continental or oceanic crust. It creates what's called a fissure, which is a crack in the ground that earthquakes can happen along. The most famous one is the San Andreas Fault, which is in California. So again, fill out the table in your notes. What you're going to be doing today is an assignment. You'll use some pages from the textbook to do that. So good luck with that.